Hello, let's continue our Sudoku adventure with A Quiver of Knockoffs by Jean. So this is not a Sudoku, this is a sum doku. I'm going to go over the rules carefully. It'll be similar to Sudoku, but not the same at all. Importantly, it is not a Latin square, so I'm going to go over the rules. Each cell is going to have a digit between 1 and 6. So it'll be a 1, 2, 3, 4, 5, or 6, just like you would expect in a 6x6 Sudoku. However, in each row, you look at the row number, row 1, row 2, row 3, row 4, etc. And that is how many distinct digits appear in that row. Exactly how many. So row 1 has all of the same digits across it. Maybe they'd be all 4s. Same with column 1. Column 1 has 1 distinct digit, 2 distinct, 3 distinct, etc. And so all of these are going to be the same. And then this column here and this row here would have 2 distinct digits. So we could, I'm not going to worry about all the rows and columns. I'm not going to try to fill out a valid sum doku here, but let's just take each row individually. Maybe we would have like 1, 1, 1, 2, 1, 2, right? That's 2 distinct digits in row 2. Then we could do like 6, 6, 5, 4, 5, 6, right? That's 3 distinct digits in row 3, etc. All the way down to row 6 having 1 of each digit, 6 distinct digits. But you remember, you also have to do the same for the columns. So we've broken this column and this column already. This is not a valid sum doku fill. But when I explain the rules, I don't really want to like try to fill out an entire valid grid. In addition to that, what's going to help us get these digits is we have these arrows in the grid. So we have a circle with an arrow attached. The digits on the arrow sum the value in the circle. So if this was 2 and 3, 2 plus 3 is 5. So we'd fill a 5 there. You can, of course, repeat digits as long as the sum doku rules allow you to. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. All right, so I think we should figure out what the single digit here is. I think this is our key. Let's think about how this works. So at minimum, we'd be 1 plus 1 plus 1, and that would add to 3. So we're at least 3. So why don't we just fill 3, 4, 5, 6 in all of these? And I'm noticing that's also going on an arrow tip. Now this is 3 digits. They can repeat, but it's 3 digits that add to this circle here. So at minimum, this is 1 plus 1. So this can't be a 5 or a 6 because this maxes out at 6, right? And a 5 or 6 would make us add to 7 or 8. So our outers cannot be 5 or 6. All right, so now here, if this was 1 plus 1 plus 1, we get 3. In order to get to 4, we add 1 to one of these ones. But I see a problem with this, which is we have the 1 and the 2, and then we also have whatever this digit is, which is not a 1 or a 2, in this row, which would be at least 3 distinct digits in this row. And that doesn't work. So this actually has to be 1 plus 1 plus 1, and then all of these are 3s. So we get a triple DT dude all at once. That's fun. Okay, so now the rest of this row has to be 1, 3 pairs. And oh yeah, and in column 6, the checker's actually telling us this. In column 6, we have 1 through 6 exactly once each, so we can't repeat the 3. So that's our 1. This could be 1 or 3. We could repeat oh, well, it can't be 1 because we can't have 2 digits adding to 1. So this is 3. This has to be a 1-2 pair, actually, because that's the only way you're adding to 3 and 2 digits, 1 plus 2. So the odd sums are very powerful because we know on odd sums with 2 digits, because you don't repeat anyway. Here we have all 1 3s. We know this is going to be the 1 because of the row. These are all from 1 or 3. Well, here we can't include any more 3s because we'd already add to 6, and we'd have to have another digit with a 1 or another 3, and that would blow out this sum. So these are definitely both 1s, which does put a 5 here. Okay, so now this column, we know what the 3 distinct digits are, the 1, 3, and 5. So this cannot be a 2. This has to be 1 plus 2 like that. And then these are only from 1, 3, 5. Definitely can't have 3 digits add to 1. We technically could put 1s in all of these. No, we can't. Okay. In order for this to be 3, this would be 1 plus 1 plus 1, but we can't repeat 1 in this column because it has all 6 digits. And so this actually ends up having to be a 5. Let's see. This row needs 3 distinct digits. There's something with that, but I'm not sure. Oh, this is just too big to be 5. Because look at this. This is 4 digits adding to this. So even if this was 1, 1, 1, 1, that would add to 4. So this is 4, 5, or 6, and it cannot be a 5 because there's already a 5 in this row. But that means this can't be a 5. In fact, 1, 2, 3. This could barely have a 3 in it. One of these could be 3. If all the other ones on the are a 1 on the arrow. But that means 1, 2, and 3 are digits in this row. Because it's row 3, we only get 3 distinct digits. We only get 1, 2, and 3. So here we already have the 1 and 3. So this is a 2. And here, let's talk about row 5 and column 5. Once we have 1 digit repeating in the column, everything else is distinct, right? Because we need 5 distinct digits. And so in order to fill that 6th slot, it's going to be a repeat of one of them. We already know the 3 repeats here. So we can't have any more 3s here, which means this can't be a 1 or a 3. Sorry, this can't be a 3. So this is a 1 or a 2. Sorry, that's all I meant to say. Now we're adding to 5 here. So that means we already have 2. That means these add to 3. So this is also a 1 or a 2. And this is a 1-2 pair. Which I don't think really does much. But now this column needs a 4th distinct digit. We only have 1s, 2s, and 3s right now. That 4th distinct digit is going to have to be lower than whatever fills here. So I don't know if this needs to be the 6 or, let's see. This is either, what's left in this row, I guess is the question. We have 2, 4, and 6 left. Well, this is definitely not the 2. And so this is the 2. Okay, that's going to help, I think. Because now we have either 2 plus 2 is 4 or 2 plus 4 is 6. But if we do 2 plus 2 is 4, then we only have 3 distinct digits in this column. We only have the 1s, 2s, and 3s. So this has to be a digit that's not 1, 2, or 3. So it has to be the 4 adding to 6. That makes this 4, which remember meant one of these could be a 3, but the rest are 1s. But I suppose, yeah, we can't repeat 3s in this column. So this can't be a 3. So this is a 1 or a 2, I suppose. I don't, wait, how are we getting, no, sorry, 4, sorry, I was thinking about 6 could use a 3. No, 4 just has to be, what am I talking about? 4 has to just be all 1s. Okay. So we already have our repeated digit here, so we can't repeat the 1 as well, so that's our 2. Also 1 plus 2 is what this had to be to get to 5. So this is not 1, 2, 3, or 6. This is 4 or 5. Here we need 5 and 6. Okay, in this row we already have the repeated 1, so we can't repeat the 5. This has to be 6. That makes that 5. And now we need 4 distinct digits in this row. That requires this to be a 4, and we're done. Right, and that does make 4 distinct digits here as well. That's why I penciled it that way. Nice. This flowed really nicely, Gene. Nice introduction to Sudoku. I'm curious, like, there wasn't a whole lot of interaction between like finding pairs and stuff like that. So kind of curious. Probably 9x9 Sudokus get more interesting. But yeah, in terms of like finding pairs, finding like more advanced techniques. But this filled out nicely and it was a nice introduction. So cool. I really enjoyed that, Gene. Good puzzle for this series for sure. Let me know how you did. I hope you enjoyed it. If you did, then why not leave a like, subscribe, and a kind comment below.